Vertex Animation store animations as relative vertex positions called keyframes. The keyframes are interpolated at runtime to produce a smooth animated result. Vertex animations sacrifice storage space for better performance in contrast to skeletal animations, which are stored more compactly but have more expensive runtime performance. The Vertex Animation class's loop boolean specifies whether the animation will repeat continuously after it has completed a single cycle. The optimized boolean indicates that the animation will be played once and then played in reverse order. This is useful for animations like breathing. The first half finished boolean indicates that an optimized animation should now play in reverse. The duration indicates the time length of the animation. The next two variables are used to interpolate between the next frame of the current animation and the next frame of another animation which is being blended with it. Their values vary from 0 to 1. The speed variable determines how fast the animation is played. The transition speed determines how fast we transition between one animation to another. Current frame represents the current frame of the first animation. Current frame 2 represents the current frame of a second animation that is potentially being blended with it. The next two variables follow the same logic. Number of vertices indicates the amount of vertices that will be animated. The target frame variable specifies the frame that we will stop updating the animation. The animation state enumeration specifies whether the animation is inactive, playing forward, playing in reverse, playing to a target frame, or transitioning to another animation. The playStandard function plays the animation forward. It first checks if the current frame is less than the total number of frames. If so, it increments the current frame by the frame speed. The integer version of current frame allows us to calculate the next frame without performing a cast. It's also used in other functions. The next frame weight subtracts the integer version of the current frame from the floating point version to get the fractional part. The if-else-if statement checks first if the current frame is beyond the total number of frames. If so, and the animation is set to looping, it resets the current frame to 0. Otherwise, it sets the animation as inactive. Lastly, it calculates the next frame using the current frame plus 1. The playStandard reverse function is the same as the previous function, but it decrements rather than increments the current frame. PlayOptimized is like a combination of the previous two functions, but it encapsulates the playing of the animation forward, then backward. The transition function increments the frame weighting of a second animation which is being blended with the current animation. The setState function updates the state and sets the frame variables to the correct value dependent on this state. The update function uses a switch statement to call the correct animation function determined by the state. The model class's setBlendedAnimFrames sets the frames and weights of the two animations that are being blended in a manner that is independent of temporal direction. This can be useful for converting the angle of fire for a turret animation into the correct animation frame. In the OpenGL client, we pass through the frame weights as uniforms. We pass through the current and next frame's vertices as vertex attributes. In the vertex shader, we use the GLSL function, mix, to interpolate between the current frame and the next frames of the first and second animation. We then use it again to interpolate between the vertex results of the two animations. The pixel shader sets up the textures for the deferred lighting stage as per usual.